Hey, how's it going? Future AMPs. Hopefully, everybody's off to a great start this week. My lecture this week is going to be on hand tools. A lot of this stuff is very much common sense to a lot of folks. Nevertheless, I would suggest for you all to pay attention to this lecture so you can know how to properly use different tools that we use in the aviation industry. To start off, when we talk about hand tools and measuring devices, the term hand tools encompasses all of the hand tools mostly or commonly used in everyday maintenance and repair stations across the United States and across the world. Some of these tools are very, very common, while others are very specialized. Different different companies use different tools, but regardless of how common the tool is, um, the proper use is always required for these types of tools. We can get started with pounding tools. So pounding tools include different types and weights of hammers and mallets, each with a specific usage. Since misuse of pounding tools can result in damage or injury to a person or to an aircraft or any aircraft component, it is important to always use all your tools properly. Before using any hammer or mallet, you should make sure that you have the appropriate eye and face protection. Depending on the type of tool, you might need ear protection. And furthermore, you should inspect the tool for any damage that could affect safety. For example, before using a hammer or mallet, you should make sure that the handle is secured and in good condition, working condition. When striking a blow with a hammer, think of your forearm as an extension of the handle. In other words, swing the hammer by bending your elbow, not your wrist. Always strike the work squarely using the full face of the hammer to prevent any marring of the work or any markings unnecessarily or unintentional markings. So keep the face of the hammer or the smooth side of the mallet free of dents. It is very, very important for you also to account for your tools. Like if you remove certain tools from your toolbox, you got to make sure that they're back in your toolbox, especially before you go home. What I would do is I would make sure all my tools are accounted for and I would lock my toolbox. Another question that has been asked by some students is like, when do I start buying tools? So I'm going to be very, very blunt with you all, is be very, very careful with the Snap-on truck or the other trucks that sell tools. I'm going to say that a good rule of thumb is if you borrow a tool from your buddy more than 2 or 3 times, then you should be buying that tool. Now, these trucks, they will give you credit. Now, what I would suggest is that don't buy everything all at once. Do not buy these $20,000 toolboxes if it's your first year. Once you start, having experience, having different types of positions, you will start acquiring tools as you go. Okay, so you should have the basic tools to start off with. We'll talk a little bit about that during this presentation, but just be very careful about debt, okay? Because these trucks will come back and start charging you, and some of these tools are so expensive. Also, be mindful about the tools you buy. If your shop doesn't use a particular tool, don't just go and get in debt because you really want a particular tool. If you don't really need it, you shouldn't be going into debt. Now, the way I did it, and you don't have to do it this way, is I would buy one tool at a time. I would buy the good stuff. For example, safety wire pliers. You should buy a good set. They're gonna cost a couple $100, but they'll last longer. I cannot really tell you the brand or which truck to buy it off. But I would say that buy yourself a good safety wire pliers because you're gonna be using those all the time. And if you got the very low quality ones, your life is going to be miserable. Now, the ball peen hammers, as you can see here, we have the ball peen hammer on the left side, and then they have the claw hammer on the right side. But I would like for you to take a quick look and get familiar with the ball peen hammer because it ranges in weight from 1 ounce to 2 or 3 pounds. One hammer face is always flat, while the other is formed into the shape of a ball. The flat hammer face is used for pounding, but should not be used to drive any nails. The ball end of the hammer is typically used to paint over rivets in commercial sheet metal. However, this is not the method used for securing rivets in aircraft sheet metal work. There are particularly bucking bars and rivet guns that are used for that particular type of job. Now, when we talk about punches, although punches are not pounding tools, they do allow the force from a hammer blow to be concentrated in the immediate area of a punch tip. This in turn means that the pressure of the end of the punch is increased compared to a hammer blow without a punch. Because of this, eye and face protection should always be worn when using punches or any type of hand tool in general. So, what I would also do is I would make sure that my punches and all my tools, I would be very, very mindful as to who would be borrowing them. I typically don't like to loan my tools to anyone just because till this day I have my tools that I had when I originally started in the aviation industry, and I take good care of them. So I would encourage you to do the same. No, so after continuously hammering a punch shank, the shank end typically deforms. It becomes like a mushroom, like the figure B on the screen here. So when this happens and you have that mushroom shape, it should be removed and returned to its original crown shape by using a bench grinder. The crown shape minimizes the chances of the punch splitting or chipping by allowing the hammer to hit it squarely. Now, I've been on skylifts, and one of my colleagues actually dropped a punch, and we were way high up in the tail of the aircraft, and the punch, when it fell, it actually just missed someone that was working inside the tail of the aircraft, and that could have been a very, very dangerous situation. So I say that so you can be very, very careful with these punches. And figure 9-7 reads that the end of the punch must have a crown shape in order to minimize the chances of splitting or chipping, right? So when you see that mushroom shape, that's when you need to work on your on the punch shank. Now the prick punches are small, sharp-pointed punches used to transfer dimensions and locations onto sheet metal for drilling. I think some of you already started some of these projects back at the Chaffey College Aviation lab. And to mark sheet metal work, place the prick punch in the desired position and then tap. Remember, tap the head of the punch with a small hammer because prick punches scar the material and have relatively delicate points. They should never be used to drive a pin or a rivet from a hole or even removing a rivet. Now, when we talk about center punches, a center punch is relatively sharp. It's really used for making those indentations on the sheet metal. The point of the center punch is ground to an angle about 60 degrees to provide an indentation that is approximately the cutting angle of the drill. Using a center punch, the punch mark should not distort the surrounding metal, but should be deep enough to so that it can drill, so you can start the drill process to cut rather than wander across the material, and it'll like you'll know what I'm talking about when your drill bit the drill bit starts like dancing and spinning all around, and what happens is you scar or you will damage all the sheet metal around. Some of the sheet metal, well, most sheet metal that we work with in aviation is also has a film of A-clad, so that is a protection for the sheet metal. So you are also destroying the A-clad when you are not using your tools properly. So one of the things that can happen is when you're working, you might be so concentrated and centered in your work that your supervisor might be walking by and will notice that you're not using your tools properly. That just made you look bad. Okay, so we don't want that. We want to stay away from being singled out for not using our tools properly. Now, the pin punches is one of the most useful punches for sheet metal workers. Uh, um, and a common use for the pin punch is to remove rivets. All right, so we use this a lot. To do this, begin by drilling through the rivet head. Try to keep it at the center and knocking it off its shank with a small chisel, or by snapping the rivet head off by inserting the pin punch and prying on it in a manner that the rivet will come off. On the figure 9-10, on the A figure, we have a hammer. A hammer is used with a solid steel center punch to mark the sheet metal. Okay, and then figure B is an automatic center punch, uses a spring-loaded trip mechanism in its handle to create a punch. It's like a clicker, almost like a clicker, and that is commonly used. If you haven't used it yet, we do have some at the Chaffey lab. Now, transfer punches. A transfer punch is a special form of punch used to mark rivet holes when using an original template to lay out a new skin pattern. The diameter of the transfer punch shank is the same as the original rivet hole, with the end ground so that it marks the new skin in the center of the rivet hole. You can see it and appreciate it here on figure 9-12. This is what a starting punch has: a flat face and tapers outward to the shank. Now, holding the tools is really important. Now, we are going to be talking about speed handles further in this lecture, but I do want to share with you that when you are using the speed handle, put all your weight into it. As you're removing these screws, I would use my tools to pick at the paint, especially when the brand new aircrafts, the paint has never been removed from the screw. I would highly encourage you to pick all the paint out of the screw, so when you go in with your speed handle, you're sitting properly, you apply the pressure and the force, and when you crack the screw, there's no paint there to pull all your force out of the screw head. So holding tools are very important to an aircraft maintenance technician. These tools can come in a variety of shapes and sizes and are designed for different tasks and needs. The proper use of holding tools helps ensure a professional looking job. However, care must be taken to use proper tool for the job. So you gotta have the right tool for the right job. Now, slip joint pliers, one of the most commonly used holding tools in aviation, is the slip joint pliers. These pliers come in lengths from approximately 4 inches to more than 9 inches. The 6-inch size is the most commonly used. Slip joint pliers gets their name from the double hole used in the pivot. The double hole design allows the jaw to work in either of the two positions, increasing the range of the material that can be gripped. Now, the teeth on the slip joint pliers can and will damage material. So be very, very careful when you are using your slip joint pliers so as to you don't damage material. Now in figure 9-15, we have the interlocking joint pliers, which have various jaw sizes as well to allow a variety of grips. Interlocking joint pliers are commonly called water pump pliers because they are often used to tighten the packing gland nut around the water pump shaft. These pliers have several curved grooves that make up a series of interlocking joints. Furthermore, the length of the handles allow a great deal of force to be applied to the jaws. Interlocking joint pliers are available in lengths from around 5 inches all the way up to 20 inches. And then these also have teeth that you should be very, very careful when you are using them, okay? And those teeth are also here in this area with the red, okay? Now, when you are using these, this nut and bolt sometimes gets loose. So what I would do commonly is I would just tighten this with the socket wrench. When we talk about vice grip, and vice grips also have those teeth, okay? So be very, very careful with these teeth and you know what you're using them for, because vice grips is the registered trademark of the Peterson Manufacturing Company for a special compound action type pliers. The opening of these jaws are adjustable by the turn mechanism that's at the end in the back here, when these handles are squeezed together, compound leverage multiplies the effort and applies a tremendous force to the jaws. A toggle action clamp, which is this toggle clamp right here, that action clamps the jaws together so that they will not open when the handles are released. The jaws are released by a small lever in one of the handles. The needle nose pliers. These are some of my favorite pliers because they help you sometimes thread or pull safety wire plier in areas where it's difficult. So there's several different designs of needle nose pliers that they're used in aviation. Needle nose pliers come in handy for electrical and electronic work because they are typically small enough to grip and hold small components and wires. Some needle nose pliers have long, thin jaws that are bent at a right angle to the handle. This allows the pliers to grip a component and hold it without your hand being in the way of the task at hand. Figure 9-7, these are duckbill pliers, and they are excellent tool for twisting safety wire because they have serrations that grip the wire, and their handles are long enough to provide a tight grip. And we talked about the safety wire plier. Please, if you're gonna spend money and you want to buy a really, really good tool, the very first tool you should buy is your safety wire pliers. A special tool used in aviation that helps you safety wire different components on the aircraft. This tool combines the features of diagonals with those of a duckbills, Safety wire pliers have a special twister built mechanism built into it that handles that quickly and efficiently twists the safety wire. To safety wire something, cut the length of the wire needed and insert it into whatever is being satisfied. The wire is then crossed close to the head of the object being satisfied or safetied, and then at the end of the wire is where you place your safety wire pliers with the serrated area, and then you pull the mechanism. After locking the handles together, the knob in the pliers handles is pulled, and the spiral rod in the handle rotates the pliers, thus twisting the wire. You can go right or you can go left, depending on the type of safety wire pliers that you have. When twisting is completed and the end is secured, the ends of the wire are cut off with the built-in cutters. And by that, we mean this area right there. Now, if you buy the expensive, nice, and durable safety wire pliers, they will have some sort of rubber. It could be red or blue. But what happens is that when you clip or cut the safety wire, the end that you're cutting doesn't fly off, right? Doesn't fly off. It actually stays with the pliers, which is a neat feature, especially if you're in areas where you don't want debris. A good example would be in the tail, the APU, the auxiliary power unit. We don't want anything damaging that component of the aircraft. Now, moving on, we also have files. Next to the chisel, the most simple cutting tool is the file. The file differs from a chisel in that it has a large number of cutting edges or points rather than a single cutting edge. A file is pushed across the material by hand, and it removes the teeth. The teeth act like a small chisel or like sandpaper, removing small chips of material. This is a good way to remove small amounts of material. The parts of the file include the tang, the hole, the face, the edge, and the point. The tang is the bend end of the file that fits into the handle, or is sometimes called the handle itself. Now, the heel, on the other hand, which is right here, the heel is the portion of the file above the tang where the main file body begins. The face of the file, which is right here, is the long flat surface used as the primary cutting surface. A file's edge is the long, narrow surface that is perpendicular to the face, while the point is at the end of the opposite of the heel. So here's your point, right? Here's the length. The length is considered from here to here. That would be your length, okay? Now, this is the edge on this side. We could use the edge depending on the job that you're doing. Now, we also have to think about how much material we're going to be cutting. So generally speaking, double cut files are used for removing large amounts of material, while single cut files are used for a more smooth finish. There are 5 gadgets of cut with regards of coarseness, and in the general, the large file or the larger file with the larger teeth can remove a whole lot more material. Now, I want you to pause here. I would highly encourage you to pause and just get a little familiar with the different files. We got the mill file right here, half round file. This is actually good to get into certain tight or curvature of different components. There's a knife file, which I have never really seen in aviation, but I know they exist. There's also the wood rasp You will be working sometimes with wood depending on the aircraft. Then also the hand file. The 3 square file is very helpful depending on the job that you're doing. The round file and the Vixen file are also more specialized, but these help you get into certain areas that you otherwise wouldn't be able to do, like with the mill file or the wood rasp or the knife file. So I highly encourage you to pause the video right now and just either take a screenshot or get familiar with these. So the use of a file. So when cross-filing, the file is moved lengthwise across the work with hands positioned as illustrated in figure 9-26. As you can tell, the individual here has the material either on a vise or has it secured so it won't move. Typically, all job sites will have a heavy-duty vise where you're going to be able to put your material or locate, fix your material. Now, be mindful that the vise also has teeth so they can damage your material. Now, what I would do is I would get a shop rag and I would put it on both sides and then slide my material in the vice grips with the shop rags folded so they don't scar, mar, or damage my material that I'm working with. And a file has it's just a simple cutting tool that could be misused. But however, in a few elementary rules are observed in storing and using files. They produce excellent results and have long service life. Now, after you're done with the file, you should clean it up. Don't just throw it in your toolbox, because what happens is that once you're done with the job, your file will have debris from the job you just performed, from removing some material. You will find some material still, material residue found inside of the file. So to ensure proper file care, use the correct type of file for the correct job. We just reviewed the different types of files that exist in aviation, so be mindful of that. The handle not only protects your hand from being gouged, it also helps you guide the file and control it. Remember, you're in control of the tool, and it also controls the amount of pressure exerted on the cutting per stroke. Secondly, match the length and cut of the file with the type of material you will be cutting and the finish that's required or desired, what you're working with, right? This makes completing the job quicker and more efficient. After a job is completed and the file is ready for storage, it should either be hung on a rack or so it does not come in contact with other files and other tools, or it should be wrapped in paper or plastic envelope and protect the teeth of the file, and should be stored in your toolbox. Now, lastly, to utilize a file properly, the type of material being filed must be taken into consideration. A good example is when filing a hard metal, apply pressure only during the forward stroke. So as drawing a file back over the material can dull the teeth. Okay. However, if filing a very soft metal, such as lead or soft aluminum, the file should be drawn back over the material to help remove chips from the teeth. Now, we're also going to include in this presentation shears. So shears are another type of cutting tool that's commonly used in aviation to cut sheet metal. Long straight cuts across a piece of sheet metal are made on squaring shears, for which they can be used really to help you, cut down the material if it's to make it a more workable or manageable size. The fabrication of more precision part requires a great deal of hand cutting and fitting. Therefore, these snips, the shears, they really come in handy. And in the next slide, we'll go a little bit into the diagonal cutters, right? So these long handled short jaw cutters allow you to get into close quarters and clip twisted safety wires and so forth. In figure 9-29, we can also add that to being color coded, aviation snips can be identified by their shape. For example, a straight snip has relatively straight nose. However, with the right cut snips, when held in your hand, a lower jaw is on the right, whereas the lower jaw on the left, which with the length cut snips, will be cutting left. Now, different brands have different colors. You should get familiar. Also have scrap material where you can test your shears out before. If you're unsure which way they're going to be cutting, test them out. Take the quick second just to like double check. Now, when we talk about drills, there are generally 5 types of portable drills used in aviation. These include the hand drill, the breast drill, also the electric drill, the pneumatic drill, and the cordless drill. I would say invest in a decent, expensive drill, okay? But remember, everything has to be gentle, okay? Everything has to be gentle in aviation. You can't just go around drilling everything and just going 100 miles an hour, okay? Now, the breast drill is one of those where it's designed to hold larger twist drills, and it could be a job that you can do by hand, okay? Here are some examples. When using a hacksaw is something that you should also take into consideration, because you will not be able to use your drill everywhere. So a hacksaw might be something that you want to keep in your toolbox for those jobs that require a little bit more specialized and more patient, more calm, more slow progress. So metal drills. Metal drills are made of carbon steel, high-speed steel, and steel alloys. Carbon steel drills typically cost less. However, they tend to overheat more readily, thereby losing their hardness. Alloy steels such as carbide are used to take drills designed for special applications. For example, solid carbide drills are used for drilling very abrasive materials like printed circuit boards, right? That green stuff. A twist drill is made up of 3 parts: the shank, the body, and the point. The shank is the portion held in the chuck. Drills used in aircraft maintenance all have straight shanks, while drills turned by large drill press typically have a tapered shank. The body of a twist drill has spiral flutes milled from the point to the shank. These flutes carry chips being cut by the cutting edge of the hole, as well as carry lubricant to the material that you are cutting and those edges. The material between the flutes is called land, and the land nearest to the cutting edge of the point, that is the full drill size, is called the margin. Immediately behind the margin, the land is ground away slightly to provide body clearance. So if we look at a figure 9-38, what we're talking about is this area here. These flutes will carry material out. Now, when you are drilling, there are some screws of different type of materials that certain drill bits will not do anything to. So you have to have the correct drill bit for the correct job. On a typical metal drill, the cutting edge on these points perform the actual cutting. The land and the flutes remove the cut material and carry lubricant into the cutting edge. So you could potentially drop oil, drops of oil here, and the flutes will carry them towards your material. I say that because you will see, if you're not using the right the right tools or the right metal drills, the drill bit, you'll see smoke. You'll see that it's really not doing anything to the material. And then almost all difficulties encountered in drilling holes with the twist drills is attributed to the dull or improperly ground point. So meaning that you're coming in not directly at a 90-degree angle. As an aviation maintenance technician, you should be able to properly grind a new drill point. Okay, so we talked about that center punch. You can start with the center punch if need be. However, there are machine shops equipped with grinding fixtures that can quickly sharpen a drill point. Use it. If your shop has it, use it. The best way to ensure a properly sharpened point is to use a grinding fixture that grinds two cutting edges that are exactly the same length and that meet in the exact center of the drill. Here, in figure 9-39, grinding the point of a drill is complicated because of the many angles involved. And because of this, it is best to use grinding fixtures whenever possible. Now the drill sizes, there are four methods used to indicate drill sizes: by the number, by the fraction of inches, by the numbers, and by size in millimeters. Number drill ranges in sizes from 0.0135 inch for the number 80 to 0.2280 inch for the number 1 drill. Fractional drills are available in sets from 1/64 inch to half an inch. Drill sizes larger than half an inch are typically available individually and are not normally available in sets. So those are you're gonna have to buy those separately. Letter drill sizes are all larger than number sizes and range from A to Z. The only drill size available in two sets is the 0.2500 inch drill, which is the letter E drill, and the 1/4 inch drill. Metric drills are measured in millimeters and are available in sets with increase of either 0.5 millimeters to the 0.1 millimeters, as we will see here in figure 9-40. I want you to pause the video. I want you to take a quick look at the sheet that I'm providing you here with. You might want to take a screenshot. This is something that will help you through your time at Chaffey. Call it a cheat sheet, if you will. Now, here on figure 9-41, most drill gauges have holes in which you insert a drill or a drill bit in the appropriate hole, and it'll tell you the size or the gauge. Now, when drilling metal with either a hand drill or a drill press, it is important to wear eye protection, also ear protection if need be. Also, when drilling steel, either a use soluble oil or lard must be used to lubricate the cutting edge of the tool. Lubrication distribution helps distribute the heat generated by the metal as you're trying to cut it. Sorry, I got some allergies, so I apologize. Now, on the right side of this slide, we have hole cutters for cutting holes in sheet metal that are larger than what a drilled or countersinking hole cutter is used. There are three types of hole cutters that are typically used in aviation. They are the hole saw, the fly cutter, and the countersink. The hole saw or circular saw is used for cutting large holes in sheet metal. This saw is available in diameters of 9/16 inch up to 4 1/8 inch. The arbor for this saw has a round shank that fits into a standard 1/4 inch electric or air drill and has a special pilot drill in the center, which helps you kind of start your project, your drill, your hole. The pilot drill has a very short body and a long shank, so that the smooth shank in the metal when the saw is cutting. This helps keep the pilot hole from becoming enlarged and holds the saw at the center. So this is something that you should get familiar with. Check it out from Justin over at Chaffey, just to like get familiar with it. So a countersink is used to cut away small portions of metal so the head of the rivet can sit flush with the surface. Almost all flush rivets used in aircraft construction have an edge angle of 100 degrees. Therefore, the most generally used countersink has a 100-degree head with an adjustable stop. Some countersinks have a fiber collar that covers the end of the stop and prevents it from scratching the work. To use the adjustable stop countersink, a cutter of the correct size is placed on the cutter shaft, and the proper size pilot is inserted into the center of the shaft. Then the body of the stop are screwed onto the shaft, and the entire assembly is put into the chuck of the 1/4-inch air or electric drill motor. Next, trial holes are countersink is scrap metal, and then stop is adjusted until the diameter of the countersunk hole is correct for the rivet size. So if we pay attention to my slide here, this is what they're talking about. If your sheet metal is like this, and you can create a place for your rivet to sit in, then it would be almost flush with the skin of the bird. So here we will have your rivet or your screw, depending on what it is, but it would almost sit flush with the skin of the bird. And your countersink will look something like this, and have the cutting mechanism here, or drilling mechanism, but you can adjust it so it'll stop at a certain depth. I hope that makes sense. Email me if you have any questions about that. So here is the stop countersinks, which are used to recess a rivet head flush with the material being riveted. The standard countersink, again, has 100 degrees, which is talking about this area here that is in red. And again, that is the same degrees that the rivet has this way. And if we think about the stop countersink, the mechanism includes the cutter shaft. It has the cutter, your pilot. It will have the body and the lock nut, and it also has a stop and a chip opening. The fiber collar is this area here that prevents any damage to the aircraft material. And moving on, we also have reamers. With a solid reamer such as the tapered reamer and bottoming reamer, only one size hole can be cut. However, with an expansion reamer, several different size holes can be cut with the same reamer. Okay, so here is the tapered at the very top. There's also a tapered spiral with spiral flutes. There's the bottom reamer, and then there's the expansion reamer here. Drills cannot make holes with sufficient accuracy for certain applications. Again, sometimes the drills will dance all over the place, will damage your materials. But nevertheless, if a hole is drilled undersized and then reamed, to a finished size, extremely accurate hole size are obtained. For example, if a structure is to be held together with both rivets and bolts, no relative motion can exist between the bolt and its hole. For this reason, close tolerance bolts are used in holes that require a light press fit to get the bolt into the hole. Reamers are also delicate, so make sure that you don't drop them. Okay, they are very delicate. When a reamer is fed into a hole, it is turned in the different direction that allows a cut to be made. After the hole is reamed to the proper or desired size, the reamer must continue to turn in the cutting direction to remove it from the hole. Otherwise, it'll get stuck in there. Okay, I want you again to please pause the video here. This is figure 9-47. This is a chart that shows both the body drill and the tap drill sizes for standard screw threads from size 0 to 80 and on. Please pause and kind of review this. I would take a screenshot just to have it handy. Now we're moving on to taps, right? So small taps are held with a T-handle tap wrench, while larger taps are typically held with a solid handle tap wrench. Both handles require two hands to turn them and operate them. When a wrench is used, a wrench is usually not used to turn a tap because pressure cannot be applied evenly on both sides of the tap, making it difficult to tap a straight hole. You want to come in at a 90 degree and you want to have total control. The three most commonly used taps in aviation are the taper tap, the plug tap, and the bottoming tap. As seen here in figure 9-49, here is the taper tap, the plug tap, and the bottoming tap. Now the taper tap at the top is used to begin the tapping process because it is tapered back for 6 to 7 threads. Now this tap cuts a complete thread when it is cutting above the taper, and it is the only tap needed when tapping holes that extend through material. A plug tap supplements the taper tap for tapping holes in a fixed stock. Now the bottoming tap is not tapered and is used to cut full threads at the bottom of the blind hole. Screwdrivers, very important. This is something that I want to just mention once again. When you have your tools, make sure they're all accounted for. Make sure you put them back in your toolbox. Very important. So here are different types of screwdrivers. You should have different lengths because different jobs are going to require different screwdriver size. Then cross-point screwdrivers. The two types of cross-point screwdrivers used in aviation maintenance are the Phillips and the Reed and Prince. These types look similar, and care must be taken to ensure use of the correct screwdriver. The cross in the Phillips screwdriver head is cut with a double taper, and the sides are not exactly parallel. Furthermore, the Phillips screwdriver has a relatively blunt point that fits into the flat bottom hole. Again, when you're working on newer aircraft that have never, which might have screws that have never been removed, they will be full of paint. Okay, so with the pick, you should be picking out the paint that you will find inside the screw head, because if you don't do this, I want you to pay attention to the screw here. This is the one I'm talking about right now. Now, let's just say that we had paint up to here, right? If there's paint up to here and you didn't pick this paint out, guess what's going to happen when you drop this screwdriver head in here. It's not going to sit flush. What's going to happen is you're going to end up stripping this screw, and you're just going to create a whole lot of work for yourself. So in order to prevent that, you should be using a pick. The pick will help you literally pick all the paint out. I typically buy the Harbor Freight picks. You don't really need those expensive ones. You can go through picks like nothing, and Harbor Freight has some very, very inexpensive ones. Now, wrenches, the majority of removable fasteners used in aircraft constructions are bolts and nuts. Therefore, it makes sense that the largest number of individual tools in a well-equipped toolbox is an assortment of wrenches. American aircraft use nut and bolts with English sizes. However, now that the metric system is becoming the standard across the globe, metric size wrenches may also be needed for aviation. With Boeing and there you might need certain sizes. With other types of aircraft, you might need a different type of wrench. Now, figure 9-62, I'm going to read it. Although most of the fasteners used in aircraft are English sizes, you may come across some of the metric hardware. The above chart are the most common size found. Okay, and they're relatively converted here. Another tool that is commonly used is the open end wrench. They have an opening in each end, and that fits on bolt heads or nuts. The openings of an open end wrench are parallel to each other and are normally angled at 15 degrees to the handle. This angle allows you to turn the nut even when the space for the handle is severely restricted. These will be your friend for those jobs that are very, very tight or confined. While the 15-degree head angle is standard, there are many other angles available. For example, one of the open end wrench has the same size opening on the both ends, with the one opening angled at 30 degrees and the opposite opening end might be 60 degrees, as shown here in figure 9-64, right? So they have different angles. Now, moving on, we also have the box end wrenches. Nuts that are exceptionally tight can spread the jaws on even the best open end wrenches. To break the torque of the tight nuts, a box end wrench is used. Box end wrenches have a 6 or 12 point opening attached to each end and offset the axis of the handle by about 15 degrees. In figure 9-65, because of their enclosed design, box end wrenches are less likely to slip. And then we also have the combination wrenches, right? So these will have an open and a closed side. These are a little bit more handy because you can use them depending on the job that you have. Now, also notice that this end has, I don't know what the degrees are, but there is a bend towards the end, right? That bend provides you with some support in getting into those really, really tight spaces. And so these are called combination wrenches. The disadvantage of a box end wrench is the limitation of always having to lift and reposition the wrench. So you're taking it out, reposition in order to continue loosening the fastener. On the other hand, an open end wrench is much easier to slip off and on onto the nut. The combination wrench has the advantage of both a box end and an open end wrench. This popular configuration has a box end, a broach on one end, and an open end on the same size attached to the other end. Here you can find it, and the answer to my question is 15 degrees. So this tool here has a 15-degree bend, right? That helps you get into those really, really tight spots. Now, some of this stuff is really common sense. Nevertheless, it is important for you to be familiar with this. Now, there are also the flare nut wrenches. As you know, aircraft fluid lines are connected to components with flare nuts. While these nuts are typically not tightly torqued, they are often situated in locations where the swing of the wrench handle is severely restricted, so you won't be able to freely move as much as you want. But to help remedy this, a special type of box end wrench is used. A slot is cut into the box end to allow the wrench to slip over the fluid line, right? To slip right over the fluid line, and then the hex of the nut is engaged each 15 degree of the handle movement, as shown here on figure 9-67. Now, this is probably my favorite tool in aviation, the speed handle. Time is expensive commodity in aviation maintenance, and therefore any tool that decreases the amount of time required for an inspection or repairs is typically used. One tool that can save a great deal of time in aviation is our handy dandy speed handle. It doesn't have to be super expensive, as long as you feel comfortable with. There are certain ways to grab your speed handle. Catch me at the lab and I will show you how to properly use the speed handle, but you got to put all your weight into it. Okay, a speed handle resembles a bow type brace and has a socket or a screwdriver bit snapped onto its end. Screws or nuts are turned much faster with the speed handle than they are with a conventional screwdriver or ratchet wrench. This is something that you should be buying. I would tuck this end right here. I would tuck this under my armpit and then place my hand here with all the force that I have, and help the other hand will come in here and help me break the really, really tight screws. You will be removing a lot of panels from aircrafts when you're doing inspections, and this really comes in handy. The universal joint have a square opening on one end that fits onto a socket drive or extension, and a male socket drive on the other end. The universal joint is used to tighten or loosen nuts and bolts that cannot be accessed with a straight extension. The swivel mechanism on these help you get into those really tight spots. So figure 9-79 has a universal joint that allows a socket or a drive to pivot independently of each other. It's really, really handy. So I would say make sure you get one of these too. Now we also have adapters that are available to allow different size sockets and drives to fit together. For example, an adapter allows a 1/4-inch drive socket to fit onto a 3/8-inch drive handle, or vice versa. This helps you really save on tools, because you'll be able to use this adapter to use on different sizes, and it'll like just eliminate the necessity to be buying different types of tools and through the use of an adapter. Figure 9-80 exercise this discretion when using the adapters, since the added force exerted has the potential to break either the adapter or the socket or strip threads on a fastener. I have never seen this happen, but the possibility exists. Now, torque wrenches. The torque wrenches must be calibrated at least once a year. that is something that your shop will be, well, I hope, is taken care of every year. The holding power of the threaded fastener is greatly increased when it is placed under an initial tensile load that is greater than the load of the fastener is subjected to. This task is accomplished by tightening a bolt or a nut to a predetermined torque or preload with a torque wrench. So typically when you have your torque wrench, it will click, and if you have the fancy ones, it will beep. I know the snap-on ones, some of them beep or light up. Whatever. You buy whatever you think is best for you. I think that the one that clicks when you hit, that one has worked for me tremendously. There's no need to be spending $500 on a torque wrench, especially if your shop will be providing those torque wrenches. So the deflecting beam torque wrench is here on figure 9-83. The torque measured by the torque wrench is then produced by the length between the drive square and the point of force of the handle. So the reading is taken here. Okay, this is how you take the reading here. I particularly don't like this, but some people feel very comfortable with them. In figure 9-84, you have a torsion bar type torque wrench. Use deflection as well as bending force to indicate the torque. A toggle torque wrench is preset to the desired torque before it is put on a fastener. When this preset torque is reached, a sound is heard and then the handle released a few degrees. The release indicates that the desired torque is reached. Once the release is reached, all force should be removed. Okay, you don't want to over torque anything. You got to refer to your maintenance manual. And here in figure 9-85, you have a toggle torque wrench which releases or snaps over when the preset torque is reached. So here's a little bit more of a breakdown. This is the force required to cause a toggle type wrench to snap and determined by the amount of compression on the spring that the wrench has on the handle, which is right here. That's where the calibration occurs. Okay, so rather than measuring the deflection of the beam, the toggle type torque wrench uses a calibrated compression or a spring to apply force to a load lever. When the torque is applied to drive square reaches the preset value, the toggle wrench forces the toggle slide bar back enough for the toggle to snap over. Scales or rules. Steel scales or rulers are essential to have in both 6-inch and 12-inch length. This type of measurement device is typically used for sheet metal layouts or for making measurements where extreme precision is not required. Scales are made in either tempered carbon steel or satin finished stainless steel and are available in both flexible and rigid form. The flexible scale typically has a thickness of about 0.15 inch, while the rigid scale is about 0.040 inch thick. Scales are graduated in exact portions of either a metric measurement or a fractional measurement. Scales with fractional graduations are typically divided into increments of 1/32 inch on one side and 1/64 inch on the other side. A decimal scale is usually divided in 10th or 50th of an inch on one side, while the other side is divided in increments of 1/100th inch. Metric graduations are measured in half millimeters and millimeters and are often included on the same scale, since it is sometimes necessary to convert from metric to fractional or decimal from form and vice versa. It is a good idea to keep a conversion chart at your toolbox so you'll easily be able to convert. But in today's world, we all have cell phones, and your iPhone might be able to do this for you just like that. Thickness gauges. Thickness gauges are used to measure clearances between two surfaces, such as piston rings, and also like clearances and gap clearances. In addition, they can be used with a surface plate and arbor to check a part for twist or wrap or warp. Sorry. A typical thickness gauge consists of a stack of steel or brass blades of a varying thickness. I think you all have experienced this already. We have many of these around the shop, or the lab, better said, which enable blades in ground to a precise dimension, accurate to 10 thousandths of an inch. Now, we also have calipers. Calipers are a type of measuring device typically used to measure diameters or distances, or for comparing sizes. As an aviation maintenance mechanic or technician, you must be familiar with the three types of calipers. They are the inside caliper, the outside caliper, and the hermaphrodite caliper, which you all have used already through your projects. Calipers are very similar to dividers in that they have two legs with some type of pivot. Inside calipers are used to measure the inside diameter of material or components or parts and have legs that point outwards. Outside calipers, on the other hand, are the opposite, right? So then those will grip the outside of the material and work its way in, which will give you the reading of the outside measurement of material, projects, components, parts, and so forth. So, in figure 9-96, inside calipers have legs with the ends that curve to the outside, whereas outside calipers have legs with the ends that curve to the inside. Now, these are not very, very accurate, but they can give you a very, very good reading with with some limitations as to standard deviations when you use this tool. Now, micro calipers, the precision measuring tool most universally used in aviation maintenance technicians is the micrometer caliper. Um, these instruments are used to measure the thickness of sheet metal, the out of roundness of cylindrical objects such as piston pins and all components of engines. Furthermore, when used in conjunction with other devices, micrometers can measure the fit of many engine parts. The basic parts of a micrometer caliper include a frame, which resembles a C clamp, and so forth. Now, here are all the different parts of the micrometer. I'm sorry, micrometer caliper. Okay, so I would say pause here and just kind of get a little familiar so you can be aware of how the mechanism. The internal threads of a spindle nut of an inch micrometer have a pitch of 40 threads per inch and are extremely accurate. The micrometer sleeve is marked with a 1-inch longitudinal line that is divided into 10 equal segments, or 1/10 inch increments. Each section between the 10th division is further divided into 4 equal parts. In addition to the mark on the sleeve, the thimble is marked in 25 equal sections, with each mark representing 0.001 inch. Therefore, when the thimble is rotated one complete revolution from zero around the 0 1 line, or 0.025 inches exposed. Micrometer calipers are also made to measure objects larger than 1 inch. This is what we're talking about, okay? So this is another slide I want you to pause and I want you to look at and observe. I am going to be uploading a video for this week that I think you should definitely review or watch. It's not mandatory, but I highly, highly recommend to watch the video. You'll find that on Canvas towards the end. And I want you to one more time pause here, and I want you to look at the readings. See how this is at complete zero, okay? Now, see how as you start moving the thimble, you're moving this way and you're starting to get your readings. Now, this is where the reading should be picked up from, right here, okay? If you haven't done so, please pause the video, review this, and also watch the additional material I will be uploading this week. Holes with diameters between 5/16 inch and 6 inches, or 8 millimeters to 150 millimeters, are more accurate, measured with a T-shape telescoping gauge. And here are, I've seen most of you use this already out in the shop. So this is what we're talking about for the small gauge and measuring. I want to say thank you, everybody. I appreciate you all. I know that this last week was a little difficult, but I want you to keep pushing through. I want you to stay motivated and have a great week. I will be uploading the quiz here shortly for this week, but also look for the supporting material for this week. I appreciate you all. Have a wonderful week. We'll talk soon.